Okay, so we're taking up homework from the sheet, solving linear relation systems, mixture of methods. We're going to start with question 4C. So you guys, in this question, and of course the pen's not working, it's when I'm explaining it. Okay, so this is question 4C. Whenever I have a fraction, what I'm going to do is I'm going to multiply by the magic number to get rid of this fraction. So step number 1 is going to be to just try to get rid of the fraction. What do you think is the magic number in this first term? Sohan? Yeah, it's going to be a 12. So I'm going to take this entire term, I'm going to multiply it by 12. I don't need to do anything to the second equation. 12 times divided by 3 is going to give me 4x. 12 divided by 4 is going to give me 3y. And then do I have to divide and multiply the 12 with the -1? I do, and so it's going to give me -12. The second equation, like we said, stays the same. It's going to be 2x plus y is equal to -8. How many of you guys did substitution for this question? How many of you did elimination for this question? All right, so just for a variety, I will do substitution for this one, and then I'll probably do elimination for the others. Okay, so in order for us to do substitution, we recognize that you have a y that is all by itself. And remember, substitution is usually done when you have a variable all by itself. So what I'm going to do is, let's call this equation number 1. Let's call this equation number 2. I'm going to rearrange equation number 2. Question? Sarah? Always get rid of the fractions first. It doesn't matter what it is. Yep, you're always going to get rid of the fractions first. Sophia? I can't remember if I did, but I'm hoping I wasn't so evil and I did. Because it's always easier to do substitution when the variable is by itself. Okay, so now you guys have to be really careful when you're rearranging this. I know when I was walking around yesterday and we did the first question you guys were working on, it was kind of tricky to rearrange it. So all I'm going to do is I want the y to be by itself. I'm going to keep this -8 here. I'm going to move the 2x over and it's going to become -2x. So our equation here is y is equal to -8 minus 2x. Does this make sense so far? Yeah. Okay, good. What is the next step after that? Sophia? Yep. Can I see how it's not letting me choose this? Why is it doing that? So I can't remember where I had stopped the recording, but basically we finished solving it. We substituted 2 into 1, and then we solved for x, we got -6, and then we solved for y, we got 4. So the point of intersection is -6, 4. And if you guys wanted to extra practice, you could go ahead and check the solution. So do a left side, right side check for both and see if you get the right answer. But then that would be your solution. Was that good? Did it make sense? Yeah? Okay. Let's keep going. Let's do question letter D. So same question number 4. We're going to do letter D. And I like this question because we didn't really practice doing anything like it. It's one with a lot of distributive stuff. So again, just like fractions, we tried to get rid of those. In the same way, we're going to try and get rid of all of the brackets that we have over here. How are we going to do that? Well, we're going to distribute, we're going to solve. We just want one letter, another letter, and then a constant on the other side. In this question, we don't have x's and y's, we have an m and n, but that's fine. It's still done the same way. So I'm going to take a look at equation number 1. Question?
So you know when you're writing like therefore the point of intersection, whatever?
Yep.
You know how you have to write like x and then y?
Yep.
So if there's no, like if it's like the variable that m and n or like
yep.
Do you just put in like any order?
You put it in alphabetical order. So in this case, I would put m in my x and n in my y. Yep. Good question. Okay, so I kind of wasn't explaining what I was doing, but I basically look at my first equation. I distributed this 2 in here. 2 times m is 2m. 2 times positive 1 is 2. Negative 1 times n is negative n. Negative 1 times negative 4 is positive 4 is equal to 15. I want to keep my m and n here. So this 2m stayed here. This negative n stayed here. And then I took the positive 2 and 4 and I moved it to the other side and I changed the sign. So it became negative 2 and then minus 4. I cleaned this up and I basically end up getting 2m minus n is equal to 9. I'm going to do the exact same thing with the second equation. Question? You solved it? I haven't solved it just yet. All I'm doing is I'm getting my equations ready. We took equation 1, we distributed everything inside the outside the bracket, and then we got rid of the brackets. We did the same thing for equation 2, and now we're going to decide. So we have equation 1 over here. We have equation 2 over here. Should we use substitution? Should we use elimination? You could you do substitution for this question easily? You could, because look, then n is all by itself here, right? So technically you could do that, but we're going to practice elimination because we did substitution for the other one. So I'm not going to use I'm going to use elimination. Okay, so in order for us to use elimination, I'm going to stack both of these equations on top of one another. We're going to have 2m minus n is equal to 9. And then here we're going to have 3m plus 4n is equal to negative 3. When doing elimination, you want to make sure that your letters all line up. So m's, n's, constants. And then you want to try to find a matching pair. Do we have a matching pair in our m's or our n's? No. Can we make one of them a matching pair? Yeah, we can make either one of them. Which one's easier? Angelique? Yeah, because there's a 1 here, so it's very easy to make this into a 4. If you were to make the m's the same, you would actually have to multiply this by 3 and this by 2. But if you try to make the n's the same, you only have to multiply the top term by it. Nirmat? You definitely could. It's just, she just said n, so we'll do n. But you can definitely do the m's as well. It doesn't matter. Samira?
So when you're trying to make like one of the coefficients or whatever the same,
yeah,
like you can only multiply, right?
When you're trying to make the coefficients the same, you can only multiply, correct? So we're going to multiply these and make them into the n's the same. So I'm going to have 2 times 4n is going to be 8m. Is that very hard to see? Probably. This is going to be negative 4n is equal to 36. And this will stay the same. So it'll be 3m plus 4n is equal to negative 3. I'm going to wake you guys up with that color. Yeah. It does not matter. So no. You have to do one of the variables. You have to make the variables the same. You can't make these numbers the same. It won't do anything. Good question though. Okay, we'll stick to this. Okay, let's keep going. In order for us to make the n's disappear, am I going to add these numbers or am I going to subtract them? Think about it. We have negative 4 and then we have positive 4 and we're trying to make it into a 0. So am I going to add them or subtract them? Good. You're going to add them together, right? Negative 4 plus positive 4 is going to give me a 0. So I'm going to add these together. This will be 11m. This will become 0n. and then this will become 33. The 0 n just disappears, so it'll be 11m is equal to 33. M is going to be equal to 3. Safir, is that what you said you got? That's fine. As long as it's something similar. Your way was longer?
Yeah, remember how we simplified the 2m plus 2 minus 10 plus 4?
Yeah.
Just kept the whole number, except for subtraction.
Oh, it's going to take you forever.
Yeah, it was a big one, but it still got it.
You still got the correct answer. Okay. But also remember, if you're not efficient, not you in particular, but if like you guys are not efficient, then you'll run out of time. So if you feel like you're stressed for time during an assessment, it's probably because you're not doing it efficiently. If you do it efficiently, the assessments can be done in like 15, 20 minutes. Shweta? No. Solve for n. This is our final step. So which equation do you think we should take? The first one or the second one? I like the first one. It's probably a little bit easier. So I'm going to say 2m minus n is equal to 9. 2 times 3 minus n is equal to 9. This is going to be 6 minus n is equal to 9. Negative n is equal to 9 minus 6. I'm really showing every step here. Negative 9 is equal to 3. And so n is equal to negative 3. So therefore, our point of intersection is going to be 3, negative 3. Just write the first letter. You guys have tried this question. It seems like, what was x again? 6, 5, and then y was 6. Okay, and we decided that we're going to do elimination for this one, just for extra practice. So, I have a hard time seeing. There we go. So what I'm going to do to start is I'm just going to rewrite these equations. So this is like saying 1 over 5x plus 1 over 3y is equal to 3. And the second one is like saying 1 over 2x minus 1 over 12y is equal to 2. What did you guys use for the magic number for the first one? 15, yep. And then what did you guys use as the magic number for the second one? 12, good. So I'm going to go ahead and do the exact same thing. Let's do this. So 15 times 1 over 5 is going to give me 3x. 15 times 1 over 3 is going to give me 5y. And I hope you guys remember to multiply this number over here as well to get 45. 12 times a half is going to give me 6x. 12 times negative 1 over 12 is going to give me negative y. 12 times 2 is going to give me 24. It seems like walking around, you guys got this step done very well. Everyone used the right magic number, and this part was pretty well done. Okay, now we said we were going to use elimination, so I can make the x's the same, or I can make the y's the same. I'm going to go ahead and make the x's the same. To me, that seems easier. If you chose the other way, that's totally fine as well. So I'm going to multiply both of these, everything here by 2 to make these x's the same. How many of you tried this question with elimination but made the y's the same? Okay, so then maybe we can compare answers because a couple of you did that. All right, so you did that as well? You did the x is the same. Okay. So now what I'm going to do is I'm going to rewrite this. I'm kind of running out of space, so I'm just going to write it underneath. This is going to become 6x plus 10y is equal to 90. And then this will be 6x minus y is equal to 24. I am going to subtract these two because it's a positive 6x and another positive 6x. And what I'm going to end up getting is 0x, which you don't need to write. 10 minus negative 1 is positive 11y. And 90 minus 24 is going to give me 6, 7, 8, 9, 66. Yeah, positive 66. Right? And so when I divide them, I get y is equal to 6. Now I'm going to solve for x. So a question was, well, do you have to use these original equations to solve for x? I'm going to say to make your life easier, just use one of the rearranged ones. They're all equivalent anyways. So I'm going to use this bottom one here. It's going to be 6x minus y is equal to 24. 6x minus 6 is equal to 24. And so X is going to be equal to 5. We need a therefore statement. Therefore, therefore, the point of intersection is 5, 6. You guys don't lose sight of what you're actually trying to find here. I'm giving you equations. When I'm telling you to solve, it's like you're graphing them and you're trying to figure out what point they're intersecting at. So when it says solve the linear system, you're just trying to figure out the point that they're meeting at without graphing it, just algebraically. This is a really good question. I liked it. I enjoyed it. Any questions about this? Okay, so that is all the review I wanted to do.